Hey everyone, so today we're going to dive into a topic that sounds like it's straight out of science fiction. We're talking about how an asset like Bitcoin is secured, not just by some clever code, but by the actual fundamental laws of physics. Yeah, you heard that right. We're going to break down how real-world energy and thermodynamics create what is essentially an unbreachable fortress for your wealth online.
It all really boils down to this one simple, but honestly pretty profound question. I mean, you can copy and paste just about anything else, right? A photo, a document, a song, you can make millions of copies for free. So why can't you do that with a Bitcoin? The answer to that is where you find the absolute genius of its design.
Because, the digital world we've built is a world of infinite abundance. That's its superpower, but for money, that's its greatest weakness. The huge breakthrough with Bitcoin was creating something that is provably, absolutely scarce and impossible to fake in a universe where everything else can be copied endlessly. It's the exception to the digital rule.
And that gets us right to the heart of the problem, what we can call the digital dilemma. How in the world do you create trust and prove you actually own something that has no physical form? Something that can be duplicated with a single click.
And this right here is the absolute key. For centuries, money was always tied to something physically scarce, right? Like gold. The internet completely shattered that link. So Bitcoin's challenge was to somehow recreate scarcity online, but not with a legal promise from a government, but with an unbreakable physical constraint.
So how on earth does Bitcoin create this physical lock in a digital world? Well, that brings us right here, to the physics of trust. The security of this whole system doesn't rely on a bank, or a company, or a government. Nope. It relies on the laws of thermodynamics.
And this quote just hits the nail on the head. It's a fundamental shift in how we think about trust. We're moving away from a system of social trust, trusting some authority not to mess with your money, to a system based on physical trust. The trust isn't in a person, it's in the fact that you simply can't fake energy. You have to do the work.
Okay, so let's put on our cybersecurity hats for a minute. How does all this physics stuff actually translate into a security system? Well, it creates what you can really think of as a massive, impenetrable energy shield around the network.
And this shield, it's measured in something called hash rate. Now, I want you to forget the idea of miners solving a complex math puzzle. Think of it more like a brute force competition. Hash rate is just the sum total of all the raw, screaming computational power from all over the globe, all competing at the exact same time.
To make this real, let's use an analogy. Picture a giant digital safe, and inside it are all the Bitcoin transactions that have ever happened. Now, this safe has a lock with, let's say, a 100-digit combination. And to make it even crazier, that combination changes every 10 minutes.
Now, there are no tricks, no shortcuts. The only way to find that combination is just by guessing over and over and over. We're talking about trying quintillions of possibilities every second. That massive global effort, that insane expenditure of electricity, that is hash rate. And the entire process, that is proof of work. The energy being spent isn't just a side effect. The energy is the lock.
Under the hood, this all works because of a cryptographic function called SHA-256. Don't worry about the name. All you need to know is it's a one-way street. It is incredibly easy for the network to check if a guess is correct once it's found. But, and this is the whole point, it is physically impossible to guess the next correct answer without actually doing the work. You can't cheat the physics.
And this is exactly what makes the ledger immutable, or unchangeable. If an attacker wanted to go back and fraudulently change a past transaction, to literally rewrite history, they would have to overpower the entire global network. They'd need to control over half of all that computing power, and not only that, they'd have to redo all the work that's already been done, plus keep up with the new work happening in real time. The cost would be absolutely astronomical. It would be economically suicidal. So we have this immense wall of energy providing security. That's the cybersecurity angle. But what does that mean from an economic standpoint? Well, let's switch hats. Because this cost, this energy, it does a lot more than just secure the network. It actually defines the money itself.
Let's just compare them side by side. For fiat currency, what's the cost to create $1 million in a digital bank ledger? It's basically zero. Creation is unlimited, and it's all backed by your trust in an authority. Now look at Bitcoin. It has a very real, very high cost of production that is tied directly to energy. Its creation is absolutely limited by the code, and its backing? It's the laws of thermodynamics. It actually brings a high cost of production back into the very definition of money.
And that's exactly why you hear people call it thermodynamic digital gold. Gold is valuable because it takes a ton of work and energy to find it and pull it out of the ground. Bitcoin is valuable for the same reason. It takes a ton of work and energy to mine it from the digital world. The value is anchored to that real-world cost.
You know, this whole concept has implications that go way beyond just finance. It actually gives us something that we desperately need in our world today, an anchor for digital truth.
I mean, just think about it. We are diving headfirst into an era of incredibly powerful AI, deepfakes, and bots. The cost to create a totally convincing fake image, a fake video, a fake identity, it's dropping to basically zero. So how are we going to tell what's real anymore?
Well, this is the radical solution that Bitcoin's design offers us. Proof of work gives us a way to prove that a piece of digital information required a real, verifiable, costly amount of energy to create. It's like a digital watermark that you can't fake. It's an anchor of truth in a sea of costless, infinite information. It's proof that what you're seeing isn't just another cheap fake.
And that's why it is so critical to reframe this whole energy debate. The energy used by the Bitcoin network isn't a waste. It is the price of admission. It's the necessary cost for creating digital truth and for securing a global, permissionless financial network for everyone. It's the cost of freedom.
So if there's one thing to take away from all this, it's this. Through proof of work, Bitcoin does something absolutely incredible. It transforms raw electricity, a fundamental property of our universe, into immutable, verifiable, digital truth. And in a world that's getting more digital and less certain by the second, what could possibly be more valuable than that?